Hi friends, in our previous video we construct a common bus, or we are going to discuss about bus and memory transfer. Memory transfer, both titles are the same, with the help of the multiplexers, right? We are going to write a big circuit with the help of the multiplexers. Now we construct the same bus with the help of the three-state buffers. Three-state buffers. So it is possible we construct the common bus with the help of the multiplexers, or the three-state buffer. The three-state buffer diagram is The three-state buffer diagram is like that, right? With the help of this one. This is the three-state buffer. So, first of all, we know that what is a buffer. Generally, the buffer is a small electronic circuit or electronic element which has the one input, this is the input, and one output. The buffer does not change any input value. That means we are given 1 as the input, the 1 as the output. Suppose we are given 0 as the input, the 0 as the output. But here we are going to be state that it is a three-state buffer. A three-state buffer consisting of two inputs. That is, the one is the normal input. I am going to be write it as a NI, normal input, and another one is the control input. I am going to write it as the CI, and the output. Suppose the output of the buffer is depending upon the control input of the buffer. That means I am going to write CI, that is the control input, NI, normal input, and this is the output of the buffer. Actually, when the CI, control input, is 0, whatever the input you are going to be given, it is not going to be produce any output. This condition is known as the high impedance state. High impedance state. That means here this circuit is like as a open circuit. That means input is disconnected with the output. The simple logic. The next one, when CI equal to 1, the buffer will work out. We are going to be given input 1, the output is 1. When CI equal to 1, that means this is enabling control input. We are going to be given the input is 0, the output is 0. Okay. By using this circuit, this small three-state buffers, we are constructing the common bus. Here a question. We are already constructing the common bus with the help of the multiplexers. Then why again we are going to be construct the common bus with the help of this three-state buffer? Means the three-state buffer size is very less. To reduce the size of the circuit, that means common bus, we are constructing with the help of this one. Here also, to construct the common bus, we are going to be consider again one multiplexer and four three-state buffers and four registers. But I am not going to be show the registers in the diagram. How I am going to draw the circuit? Please observe carefully. So this is the first three-state buffer. This is the input and this is the output. One buffer is connected to the one bit of the register. Let us consider this is the A0, or let me consider the buffer is connected to the entire register. This is the register A, and please write like that. This is the second buffer, I'm going to be connected this one. This buffer is connected to the one bit, first bit of the second register. Again, actually, this is the third buffer. This is connected to the first bit of the third register. This is the fourth buffer. This is connected to the first bit or one bit of the register. By connecting all these, let us consider I am going to be connecting this one to this one to this, and this one to this. All these are interconnected. Now this is the common bus. This is the common bus. Now we know that the buffer has two inputs. One is the normal input, other one is the control input. To connect the control input, I am going to consider this one. Actually, one 4 by 1 multiplexer. 4 by 1 multiplexer. It has the four inputs, right? That equal to 0, 1, 2, 3, and two selection lines that equal to S0 and S1. Now based on that one, now I am going to connected the output. Sorry, I am not going to be use the multiplexer. I am using the decoder. I'm sorry, I'm using the decoder. I once again I write this diagram. Please sorry, I'm extremely sorry. I'm going to be use the decoder, right? Please wait 1 second. Now I'm going to be use 2 by 4. I'm using 2 by 4 decoder, right? How the 2 by 4 decoder is working, I will explain here. So, sorry, I am not going to be use the multiplexer. I am using the 2 by 4 decoder. Decoder is also a combinational circuit which accepts two inputs and generate the four outputs. That is n inputs it accepts, 2 to the power of n outputs it will be produced, right? Now I am going to be write a 2 by 4 decoder here, right? 2 by 4 decoder, right? This is known as the S0, this is known as the S1, right? Now I am going to use the enable input, that means E. Suppose the E equal to 0, the decoder not going to produce any output. When E equal to 1, the decoder produce the output. Now the first output of 0 output of the decoder is connected to the as a control input of the first buffer. The first output of the decoder is connected to the control input as the second three-state buffer. The second output is connected to the as a control input to the third one. The third output of the decoder is connected to the control input of the fourth buffer. Now we are going to be consider now S0, S1 and S0 values that equal to 0, 0. The first output of the decoder is enabled. That means 0 decoder 0 output is enabled. that means this is 1, is transferred. It acts as a control input to the buffer. Here, the content of the register A is transferred to the here register transferred to the common bus, that equal to 0 1, right? The uh, first output of the decoder is enabled. Now the content of the register B is transferred to the common bus 1 0, that equal to the second output of the decoder is enabled. It acts as a control input to the third three-state buffer. Now the content of the register C is transferred to the common bus. In the same way, 1 1, the third output of the decoder is enabled. That means it makes 1. Then the content of the register D, what is here, is transferred to the output of the common bus. Okay, friends, I hope you can understand this one. Please consider, here we are going to be used 2 by 4 decoder. I show the diagram also, the content also. Please carefully observe the document. This is the document I am going to be submit. So this is the structure of the three-state buffer actually, and this is the just what we are going to be explain this one. Here I am going to be use 2 by 4 decoder. S0 S1 values are 0 0. The 0 output of decoder is enabled and act as a input control input to the first buffer, like this. I hope you can understand this one. Thank you.